Hello, everybody. This is Dr. Kevin Connors. Welcome to Labs 101, where we're going to talk about basic physiology of the GI system. And this is going to be boring for those who don't like physiology, but physiology is everything. You should love this. But I think it's important to understand this for a number of reasons. When you're trying to figure out and put on your Sherlock Holmes hat to figure out what's wrong with you, you got to know how things function. And the more you know how things function, the better you'll get to see that picture in your head to understand why you do things. And I know this is under labs because this gives you a clearer picture of why you would want to run certain labs. It's not just to run certain labs to find out you have this disease so you can slap this name tag on your collection of symptoms. It's to know the physiology of what's taking place so that you can know how to figure out then what do you do about it. I hate the practice of medicine where we just run labs in order to give a diagnosis. It doesn't help at all. And then we look at the Merck manual to figure out what we're supposed to do with this diagnosis, and it's usually a drug. It's idiotic. We got to find out the physiology. Why is it happening? You got to dig a little deeper. So, in order to do that, we got to look at the whole digestive system, how it works, how it starts. So, bear with me through this. If physiology and biology was not your forte in high school or college, um, just start to absorb some of this stuff. Absorb. Right? We're talking about the digestive system. Absorption is important, right? Digestion is important. So I'm going to try to digest these concepts for you too. Hopefully you're not going to excrete them as soon as we're done with this video. Sorry, I have a bad sense of humor. Main functions of the GI system is digestion, breakdown of different foods. You're talking about things that you eat, right? So it has to be broken down into a particle size that you can then absorb it. So absorption is the next step. If you can't absorb things through the gut wall, well, you're not going to get any benefits of the great nutrients that you're consuming. And then if you can't get rid of the bad things, the end products of a detoxification, well, then we're in big trouble. So these are very, very important, and we're going to hit these. We hit these. I literally talk about these three pieces throughout this whole chronic disease and autoimmune course. Throughout all the courses, you talk about serious diseases like cancer and stuff. You can't argue that at least a piece of it starts in the gut. When you really understand the physiology of the gut, at least a piece of all disease starts here, if not all of it starts here. So the breakdown of foods into the particles that you can absorb and the proper absorption, which has to do with the health of the lining of the gut, which I'll show you in this slide right here. The health of the lining of the gut, you have these cells of the gut called epithelial cells that line the gut. We're talking about the small intestine. This is a picture of that. You have these villi, these little things. The top of the slide is the lumen, the blue part. That's the lumen. That's the inside of the tube, inside of the intestine. That's where food is traveling. And the food then is broken down, hopefully, before it gets to the small intestine. The majority of it is already digested. We'll go over that ad nauseum. But then it gets absorbed through the gut cells. And it goes through the cells of the gut and into the bloodstream. And then the cells of the gut are packed together tight. And those are called tight junctions. Yeah, physiologists don't have any fancy name for those connections between the cells. They're called tight junctions. And when those tight junctions get damaged, those cells separate, things get across the lumen into the bloodstream. So, you really think of it technically. When you eat something, let's say you swallow heavy metals, okay? Pretend you were sucking on a piece of lead. Oh, that's poisonous, it's dangerous. Really, you shouldn't absorb that. It should be large enough that you shouldn't absorb it. It should go through the tube, through the intestinal tract and into the toilet. You really shouldn't, that you should go and suck on some lead, but you shouldn't absorb it. The problem is you will. Why? Because almost everybody has damaged gut border of some degree. Some people it's really damaged. Some people it's just slightly damaged. Some place in that intestinal tract of 30 feet, there is a damage in the tight junctions, and things will go across that should never have gone across that, and then will get into the bloodstream, and once they get into the bloodstream, they are a poison and they cause all sorts of problems. And that's what we talk about in detail when we talk about food allergies. This is how food allergies tie to that. Why are you allergic to a food? Because it never got broke down to the point where it should have, and been able to cross the border of the gut wall into the intestines as a nutrient, as a micronutrient. It may have gotten through as a macronutrient through a broken tight border, and therefore your body couldn't recognize it because it's not a micronutrient, it's not fully digested. It creates antibodies against it. Now every time you eat that food, you have antibodies against that food, causes an inflammatory process in the gut, which then further damages the gut wall, and it's this negative cycle that takes place. We'll go over that in other slides, in other presentations, when we talk about food sensitivities and why you would test for those. But this is the general physiology of a healthy membrane, a healthy border, healthy boundary. Really, when things are in the lumen of the gut, they're still outside of your body. Well, whether or not I swallowed it, well, it's not really technically inside your body, if you can think of it that way, until you absorb it. So if you have damaged cells, you can't absorb nutrients well, so you're not getting the benefit of the nutrients. And if you have damaged cells, you can actually absorb things that you shouldn't absorb. I hit that kind of hard. So let's go through digestion first. So digestion, where does it begin? Well, it begins in the mouth, right? Well, it actually begins in the brain. I mean, think of it. You could just think about your favorite food and you start to salivate, right? That salivation is secretion of fluid, but also enzymes from the salivary glands. The purpose of amylase and ptyalin from the salivary glands is it starts to break down in the mouth carbohydrates primarily. And the act of chewing breaks down food into smaller particles. The whole idea of digestion is to break things, macronutrients, down into micronutrients. So you're breaking things down into a size, molecular size that's small enough to go across a healthy gut border. That's the whole purpose. So maldigestion, the fact that I'm not able to break down foods into a size that's healthy enough to go across small enough to go across a healthy gut border is maybe the number one cause of ill health worldwide. Maybe it's at least a factor in all disease. Let's say that, all right? Because if you can't break down food to this healthy size to go across, the small enough size to go across a healthy border, then you could end up creating antibodies against these particles that causes inflammation. It causes inflammation every time you eat it, and it causes more damage to the gut border, and it causes this whole cascade of problems. So digestion is really important. Chewing causes the release of HCl in the stomach. That's why I'm not a big fan of chewing gum on a regular basis, because when you're chewing gum on a regular basis, you're causing secretion of HCl in the stomach, and you could basically wear out those cells that secrete HCl. You can also damage your stomach lining by having too much HCl in the stomach when you don't have food to break down, and then when you do eat, you're not secreting enough HCl to break down the food, and then you get food that is only partially broken down because of a decreased HCl production that's going into the small intestine much larger than it should. Remember, I said that's a major problem. That is quite possibly hypochlorhydria. Decreased production of HCl at the correct time is quite possibly the number one health problem worldwide that can lead to more serious disease. And it's overlooked by the medical profession. They don't even address it. And that's something we'll talk about. So when you chew, when you think about food, certainly when you get food in your mouth, you start chewing. Your brain is really what starts everything off, stimulates the vagal nerve, cranial nerve 10, to secrete uh, saliva from your salivary glands, which has enzymes in it. Your brain, your vagal nerve stimulates your stomach to secrete um, uh, HCl to prep for this food that's going to be coming down the esophagus. So your nervous system controls everything, and then you're breaking down food by chewing this up really good. You learn how to chew your food a lot, and it's broken down, the act of digestion, so that then it can go into your stomach. And in your stomach, you have that HCl where it's going to start to break down more and more of the proteins, especially. The brain also releases histamines that help release HCl. So it's really important, your brain and your vagal nerve control really everything. And many times that's overlooked by functional medicine practitioners, the neurology behind digestion. And I talk about that a lot when we talk about with our cancer patients, because it's the vagal nerve stimulation that stimulates digestion, that stimulates relaxation, that stimulates your immune function, that stimulates detoxification. So that's why somebody who has detoxification issues, doing vagal nerve exercises, doing coffee enemas. I have a whole list of vagal nerve exercises in that module and in the chronic disease module, because it's so important. Your neurology of physiology is so important. That's what causes the release of the hormones and causes the function to take place. In the intestines is where absorption really takes place. Food enters the duodenum, combines with enzymes from the pancreas and the bile and the gallbladder. This is the act of digestion and breaking down foods. Now, here's a picture of the intestinal wall itself. Food travels in the lumen. That's my arrow to the lumen. That's where food travels. But you have glands in the mucosal lining that function to help lubricate the intestinal lumen and help keep the cells of the intestinal lumen protected. Acts as a protective layer as well. You have ducts that feed right into the lumen. These are ducts that feed the enzymes from the pancreas and feed bile from the gallbladder, which is housing the bile that's created in the liver, which is essential for digestion of fats, and bile carries the waste from the liver through phase 1 and 2 detoxification pathways. That's how that waste then is carried into the small intestine. And again, if you don't have a healthy border and healthy epithelial cells, you could then just reabsorb that waste and carries into the blood again, and your liver is going, what the heck? Why am I seeing these toxins again? I work so hard to get rid of and put in the bile and get into the small intestine, and now it just reabsorbs again. So damage of the epithelial cells that line the gut is a key component of a lot of diseases. It's really what causes what is called leaky gut or intestinal permeability issues. So then we reabsorb things that we have already detoxified through the liver, and we absorb things that we never should have absorbed, poisons, toxins, pathogens in our intestinal tract that, because of things that we're exposed to environmentally, dietary, etc. Absorption takes place in the gut through the arteries, so it crosses across that epithelial lining and goes into the arteries and then circulates through the body, and hopefully it's nutrients that is going to give nutrition to the body and heal our body. That's the goal of this. All is controlled by the enteric nervous system, primarily under the vagal nerve, um, that not only controls all the secretion of enzymes and the function of the cells, but it controls the muscle layer, causes the contraction of the muscles to move food through the intestinal tract to so it can be absorbed and ultimately the waste can be excreted. Take a closer look at the stomach itself. The esophagus comes into the stomach, and common issue with esophageal ulceration, that's common when a person has issues with the sphincter. That sphincter is a muscle layer that contracts and it relaxes again by the function of the nervous system. So the parasympathetic, sympathetic nervous system control that sphincter function. A sphincter is just simply a muscle that's going around that tube so that it keeps food in the stomach and allows food from the esophagus coming down from the mouth to go into the stomach. But it's that sphincter in the top part of the stomach, it's called the cardiac sphincter, and the sphincter that releases food from the stomach into the duodenum is called the pyloric sphincter. That cardiac sphincter is really important because if there's issues with that sphincter, it can cause regurgitation of acid into the esophagus and cause esophageal ulceration. The cells of the esophagus can become damaged, and that can cause all sorts of issues. Primary concern with the cardiac sphincter also is a condition called hiatal hernia. Very, very common. It's very common in little babies because that sphincter hasn't quite yet formed. And I have a whole video on hiatal hernia correction, or at least management of hiatal hernia issues. And I'm talking about functional hiatal hernia. If it's gotten too bad, surgical intervention sometimes is necessary, but most of the time it's a functional problem. Look up in my blog, hiatal hernia. You'll see I created a video how to pull that down. That can help your body heal that. And then the cells that secrete and make HCl are in the belly of the stomach, for use of a better term. And let's look at that because it's important. You got these different cells that, this is what the histology of the stomach is. It's like, this is getting too deep here, but it's important. These cells secrete gastrin hormone, and enhancing gastric mucosal growth, helps the growth of this mucosal lining, the health of this mucosal lining, helps with gastric motility. You need motility and stimulation of the muscles that line the stomach in order for food to then pass through this, and this to be squashing around and moving food around so that it can be basically like a washing machine. So HCl, hydrochloric acid, can surround that bolus of food and break it down. That's the whole goal of it. Remember, our goal is to break down food at this point. We're breaking down these macronutrients into micronutrients. And secretion of hydrochloric acid is essential, and pepsin into the stomach. And HCl, again, I said hypochlorhydria, or decreased HCl production, is in my opinion, the number one cause of ill health. And why? Well, I don't have HCl production. I have parasites. Well, if you have a decreased HCl production in the stomach, you're not going to break down and digest food, protein, and carbohydrates very well at all. And then that's going to cause all sorts of problems, and we'll go in depth in that. HCl production is your first line of defense against foodborne pathogens, and you eat a lot of them. There's pathogens in our food. It's not just, horrible pathogens like E. coli that's going to cause a real bad sickness. It's just normal pathogens. You're exposed to them all the time. You breathe them in. It goes into your mouth, and you swallow these foods. Your saliva doesn't really protect against pathogens as much. You do have microbiome in your mouth that helps with that, but when you swallow, it's that HCl balance, that pH of 1 to 2.5 pH on the pH scale. It's extremely acidic. That pathogens can't live in that. It's killing that level of acidity in your stomach is killing those pathogens. HCl production, in turn, this is something much overlooked, produces sodium bicarbonate. It's a major player in buffering pH systemically. So, kind of a what I deal with some cancer patients is they'll say, I started taking sodium bicarbonate, the baking soda, because that's a cure for cancer because I'm trying to alkalize my system, or I'm drinking alkalized water because I want to alkalize my system. And that just grates at me because you're missing a understanding of physiology. Whoever's teaching this stuff is not understanding physiology, because your pH of your stomach needs to stay at 1 to 2.5. If you're drinking sodium bicarbonate or you're drinking high pH water, you're missing the point. You're actually alkalizing your stomach, and you're neutralizing the HCl. You're neutralizing the acidity of your stomach, and this can lead to all sorts of problems. That's not how you alkalize your system. That's not how physiology works. You can't drink sodium bicarbonate and think that's going to alkalize your tissues. All you're doing is alkalizing your stomach and causing malabsorption, maldigestion, all sorts of problems that come with hypochlorhydria. Don't do that. When you produce HCl, you are actually producing as a side sodium bicarbonate that's secreted into the bloodstream. And this is a major buffering part of your system. Your body is constantly buffering pH. You will maintain a pH of 7.4 or 7.34, something like that, in your blood, or you will die. And the way you do that is you pull nutrients, particularly calcium and minerals, from the bone. That's part of your buffering system, and the production of HCl, because that buffers your blood. So when you hinder HCl production, or you have a decreased HCl production because of damage of these gastric cells, because of a poor diet, because of food sensitivities, because of chemicals and exposure to glyphosates and mycotoxins and all these things, then we have all sorts of ill health that comes with it. HCl is also essential for B12 absorption because it ties to intrinsic factor. Now, when you look at the cells in the stomach, you got all these little villi type cells like this that are so important, and we can't overemphasize. This is why we do autoimmune testing on these cells. So this is a Cyrex Array 5 multiple autoimmune panel that we have a lot of people do through our autoimmune course. And the reason why we look at these things is because if I have antibodies to the parietal cells of my stomach and antibodies to intrinsic factor, then I am just basically destroying these cells. So we need to calm down that autoimmune reaction if I have antibodies to these cells. So you go from a stomach that has these beautiful villi like this to a stomach that's just flat. These cells are damaged. Therefore, you're not producing HCl, and this becomes a huge, huge, dangerous negative cycle in a person's health picture. So we can't overemphasize the understanding of the anatomy and physiology of the GI system in every system to really understand the functionality and how we're going to correct these things. Then we move into the small intestine, where you have pancreatic secretion of enzymes. Your pancreas secretes trypsin and chymotrypsin to digest proteins, amylase for the digesting of carbohydrates. Remember, your salivary gland also produces amylase. You have lipase to break down fats. Lipase is also present in bile. Again, I'm going to emphasize why digestion is important. You have, just using proteins as an example here. Proteins are broken down with HCl and pepsin and multiple other enzymes. Simplifying here. Denatures breaks down that protein. Proteases, these are other enzymes, break it down into peptides, and then ultimately amino acids. And amino acids then are small enough, these individual amino acids then can cross the lining of a healthy lining A healthy border, a healthy intestinal border needs an amino acid or two amino acids, what's called a dipeptide, that size. If it's any larger than that, a healthy border won't allow it across. So I love this picture. So you got, think of a protein as this long chain. This is showing six, balls here, but it's actually like 100 and some, amino acids in a chain that makes up a protein. And then these enzymes, this case protease, is like a scissors that's going in there and cutting this up, cutting these connections up into single balls. And each one of these balls is a different amino acid. That's the idea of digestion. It's taking a protein and breaking it down to amino acids. But it doesn't do it all at once. It cuts it into a chain of, some 15 links, and it cuts it into a chain of 7 links, and it cuts it into a chain of 20 links. It's breaking it up into pieces as it's acting upon those junctions, those bonds between the amino acids. So these enzymes act on these bonds between the amino acids in the protein structure to break it into peptides. If that's a protein, might be 115 amino acids. A peptide of that protein might be 22 or 15 amino acids, ultimately breaking down to individual amino acids, or what are called dipeptides, 2 amino acids bonded together. And that's the size that should be able to cross the intestinal wall. Why do I hound on this? Because when we have a damaged intestinal wall, we can get peptides of a chain of 15 or a chain of 22 that cross the intestinal wall that should never cross. Gets into the bloodstream, and literally your immune system is going, what in the Sam beans is that? Let's attack it. So it starts trying to attack it. Of course, it's not a living organism. It's never going to kill it. And then it ends up developing antibodies because it fires a B cell response, develops antibodies against that. And now you have antibodies against these peptides of a food. This is how you develop food allergies. This is how you develop food allergies. You have amino acids against peptides of gluten or dairy. And now, when these peptides are seen in the lumen of the gut, you have antibodies in the lumen of the gut. So when you have antibodies against that, guess what's going to happen? You're going to fire an immune reaction against it, which is inflammatory. Now you got this inflammatory response going on in the gut. This is the cycle of inflammation that will further damage the gut border and cause this negative cycle, destructive cycle. So important to understand this physiology. Small intestine is where absorption really takes place. I said the pancreas secretes enzymes. This is why you would want to take pancreatic enzymes with your food. This is why you'd want to take HCl and pancreatic enzymes with your food. This is why our product, Clear Digest, has pancreatic enzymes, HCl, bile salts, because we're helping support digestion. If you could only take one supplement, that's what it would be to take, is take that with your food. Take a product like our Clear Digest or something like that has HCl, pancreatic enzymes to digest all the macronutrients, bile salts to help support bile production. Even if you don't have a gallbladder, you're still secreting bile into the small intestine, but not at the rate secreted when you have a flux of food there, just at a trickle all the time. That's why you need sometimes to add bile salts to your diet. And your liver, gallbladder, creation and release of bile. Remember what bile does. If you've studied the 7 phases of detoxification, bile isn't just secreted into the small intestine in order to help digest fats, because that is a function of it, but bile carries the endpoints of the liver's detoxification process. So the liver, through phase 1, phase 2, phase 3, making bile, puts all its poisons that it's pulling out of the blood through phase 1, phase 2 detoxification into the bile, then secretes that into the duodenum, that first part of the small intestine, to hopefully travel all the way through the gut and out into the toilet. Problem is, if we have leaky gut issues, you reabsorb it. So I hounded on that. We'll talk about that more in a later module. Absorption in the small intestine is through the villi, which give hundreds and hundreds of times more surface area to the gut so that you can absorb nutrients. We talked about damage to that gut border that causes issues that needs to be healed. You have a microbiome in the gut that function to produce butyrate or butyric acid as they feed on indigestible fibers that you're hopefully eating. Butyric acid is so essential in healing the epithelial cells. It's the main food to heal the epithelial cells is butyric acid. Microbiome makes nutrients, different vitamins, assists in digestions, help keeps pathogens in balance, helps produce natural antibiotic effects, helps minimize microbe growth, recycles bile salts, on and on and on and on. So there's just dozens and dozens of functions of a healthy microbiome, not just in the gut, all through the body. We'll talk about that in a later module. The large intestine, there's some absorption that takes place. You have water reabsorption. Important to note that if you have stasis of feces in the gut, it is the #1 place where you'll reabsorb bad estrogens. So you can reabsorb hormones in the gut that you don't want to absorb. So you want to make sure that this, what I call phase 6 of your phases of detoxification, is healthy, and you're moving your bowel on a daily basis, at least once a day. You're getting out what's on the inside. There's just it's just so important that exit of waste is taking place. Thanks for sticking with me. I know I went fast, but you guys know all this stuff. So, but it's important just to have that review of physiology. I just think it's just helpful as we get into understanding why we would run different labs and tests and what they mean. And it's also helpful, if you understand physiology, I think it's very helpful to combat falsehoods that's out there too. There's a lot of, the wrong teachings too that I think you need to combat as well. All right, have a blessed day, and we'll see you at the next video.